Hello everyone. Hello everyone. Our topic for discussion for today is the formation of hemoglobin. So let's discuss how hemoglobin is formed. So hemoglobin, it is one of the most important components of a body. It is present in the blood. It carries various gases like oxygen and CO2 from one place to another, and it is the pigment which provides color to blood. So with this basic information, let's proceed to the synthesis of hemoglobin. So the two components required are glycine, which is an amino acid, and glycine is the only amino acid which is not optically active because its R chain has hydrogen, and thus the carbon is non-chiral. So this is some information, extra information about glycine, which is not much required, just some extra information. Now let's proceed towards synthesis. So first we have glycine. Along with glycine we need succinyl CoA. Glycine plus succinyl CoA will first combine in the presence of the enzyme ELA synthase. Now, what is ELA? They both combine to form ELA, which is delta amino levulinic acid. This is what is ELA. Now, this step is the rate limiting step of the cascade of reactions. Along with the enzyme ELA synthase, we also need a coenzyme, that is PLP or pyridoxal phosphate. It is also the active form of vitamin B6. Now this alpha levulinic acid is prepared by ELA synthase, the enzyme. Now there are two isoforms of ELA synthase. One is ELA synthase 1, another is ELA synthase 2. Now ELA synthase 1 is present in all the tissues of the body, but ELA synthase 2 is very specific to only erythroid tissues. Erythroid tissues like bone marrow, liver, spleen, okay? Now, there is some extra information that I would like to tell you is mostly all the reactions of a body, they are under the control of a negative feedback because we do not want excess production of anything in our body. Similarly, in this heme production also, when the amount of heme is more, that means our body is having excess of heme and we do not require the body to produce more heme. The ferrous form is being converted into the ferric form, and hence heme synthesis cannot occur. And this ferrous form in its ferric form, it is called Haem. So heme, which has iron in 2+ form, is changed into 3+ form to form Haem. As Haem is produced, the activity of ELA synthase 1 decreases. Now, why activity of ELA synthase 1 decreases? This is because Haem represses the transcription of gene for ELA synthase 1. Haem also causes destruction of its mRNA. It also inhibits the transport of the enzyme into the mitochondria, which brings me to the point that this synthesis, the first step, starts in the mitochondria. Now, what did Haem do? So we saw that when body has an excess of heme, the 2 plus iron is converted into iron 3 plus form to form hemin. This hemin reduces the activity of synthase 1. If the activity of synthase 1 is reduced, then the production of heme or hemoglobin is reduced. Now how does hemin does it? First of all, it inhibits the transcription of the gene for synthase 1. If transcription does not occur, then mRNA is not formed. Secondly, it also causes destruction of mRNA. Now, if mRNA is destroyed, then protein cannot be formed. And if some hemoglobin is, and if some synthase is still formed, then what hemin does, it inhibits the transport of the enzyme into the mitochondria. So it interferes with the production and the transport of hemin at all, and the transport of synthase at all the 3 steps. I hope this is clear. So and the activity of synthase 2 does not depend on the quantity of heme. So this means it has a constitutive activity. Its activity does not depend on the quantity of heme. Well, that is an important point. And one more question regarding synthase 1 that we get is, why intake of excessive drugs like phenobarbitons lead to precipitation of porphyria? This is the question that we frequently get. Now the answer to this is, we know that drugs are metabolized by cytochrome P450 monoxygenase system. Now this requires heme. So drugs are metabolized, but heme is utilized. So amount of heme decreases. So if heme decreases, activity of synthase 1 is increased. So if there's increased activity of synthase 1, there will be increased production of heme. Now, what is the problem that we have in porphyria is that there is some enzyme deficiency at any of one of the step of the heme synthesis. So it leads to production of some intermediates, and these intermediates are called as porphyrins, and these porphyrins excessive production leads to porphyria. Now if the activity of synthase 1 is increased, then the production of these porphyrins will also increase, which will lead to increased porphyria, and hence there is a precipitation of porphyria. I hope that it is clear to you all. Now, so we had a big discussion. So this was every possible question which we could get out of the first step of a reaction. Now let's move to the second step, and these steps are still happening in the mitochondria. So now we have produced that is alpha delta aminolevulinic acid. Now 2 ALAs will combine in the presence of dehydratase, this enzyme, and zinc is the cofactor here, to form PBG. Now what is PBG? It is porphobilinogen. They will form porphobilinogen. Now this enzyme dehydratase, it is very sensitive to lead. Why? Because lead can displace zinc, and if lead displaces zinc, this enzyme cannot function. Hence in lead poisoning, there is inhibition of dehydratase. This is an MCQ point, that lead poisoning leads to the inactivation of enzyme L dehydratase. Why? Because it replaces zinc, and this is responsible for anemia. Okay, then now this porphobilinogen, it comes out of the mitochondria into the cytoplasm. Now next reactions will occur in cytoplasm. Now what happens that we take 4 molecules of porphobilinogen. These 4 molecules of porphobilinogen will form a linear molecule. Like these 4 molecules will join to form a linear molecule, and this molecule is known as linear tetrapyrrole hydroxy ethyl bylane. No need to remember such a long name. Just remember that a linear tetrapyrrole molecule is formed. Then this molecule undergoes cyclization and isomerization. That is, the linear molecule changes into some cyclic structure. That is what is occurring, and this cyclic structure which is now formed is known as uroporphyrinogen 3. Okay, this uroporphyrinogen 3 is formed. Now what happens? It undergoes decarboxylation. So the enzyme is uroporphyrinogen 3 decarboxylase, or uroporphyrinogen 3 decarboxylase. This is the enzyme, and then it forms coproporphyrinogen 3. Now this molecule will enter mitochondria again. Now it enters mitochondria. So after entering mitochondria, it undergoes several changes to finally form protoporphyrinogen 9. Now this protoporphyrinogen 9 undergoes oxidation to form protoporphyrin 9. This protoporphyrin 9 combines with iron in the presence of ferrochelatase enzyme to form heme. Now, or this reaction can even occur spontaneously. This ferrochelatase enzyme is also inhibited by lead. Now finally we have our heme formed. So these were the main steps and the reaction which was occurring in the formation of heme or hemoglobin.